السلام عليكم. Excuse me, let's start. Let's start our session. The first speaker is engineering Mahmoud Al-Tayyib. He is AFRAC MRA committee chair. باشمهندس محمود طيب صراحة هو غني عن التعريف، هو رئيس لجنة الاعتراف الدولي المتبادل بالمنظمة الأفريقية للاعتماد. هو ممبر في ال ILAC Accreditation Committee of Arrangement Management Committee, former Executive Director of IJAC، ودي المؤسسة المصرية ال Third Party for Accreditation in Egypt. He is a former chair of ARAC اللي هي المنظمة العربية للاعتماد, regional evaluator with region ABAC و ARAC و AFRAC for evaluation of accreditation bodies. He is also an international evaluator for ILAC. فيعني زي ما احنا شايفين كده بسم الله ما شاء الله هو نقدر نقول ال godfather of accreditation بقى in Egypt. Welcome engineer محمود طيب.
شكرا يا دكتورة على التقديم. ألف شكر لحضرتك. Thank you. مش عارف نتكلم بيور انجلش ولا بوست يعني كده وكده. اوكي طيب. صباح الخير على حضراتكم جميعا. Today we will have overview on accreditation of Biobank. Actually we are talking about the quality in Biobank. Once we are talking about the quality, it means that we need to see what's quality infrastructure, and accreditation is one of the pillars of quality infrastructure. Actually, quality infrastructure has 5 pillars. First one is the standardization, metrology, the conformity assessment, accreditation, and market surveillance. The time is very limited to speak about quality infrastructure details, but today we are going to speak about accreditation only, about the as one of the main pillars of quality infrastructure. Actually, accreditation system is, it has international system for accreditation, and we need to go to the international system of accreditation, how it works. This is the international system of accreditation. If we look at the bottom of this slide, you will see conformity assessment bodies. So what's conformity assessment bodies? Calibration labs, testing lab, medical labs, biobanks, professional testing providers, inspection bodies, reference material producers. Those are the conformity assessment body. Today we are going to work with the biobank in specific, but this is the international system of accreditation. The conformity assessment body, the role of the conformity assessment body is to ensure the quality of the services and the products provided to the customer. Actually, this is the role of the conformity assessment body. Actually, once the conformity assessment body role is to evaluate the competence or the quality of the services. So who is responsible to evaluate or to assess the conformity assessment body? This is the role of the national accreditation bodies. So the role of the national accreditation body in each country mainly is to assess the competence of the conformity assessment bodies, including calibration lab, testing labs, biobanks, professional testing providers, or reference material producers. And after assessment, they ensure about the quality of services provided by those conformity assessment body to the customers. Once the national accreditation body role is to evaluate or to assess and ensure the quality of the conformity assessment body, so who is responsible for evaluation of the national accreditation body in the world? Yeah, this is the role of the regions, or what we call it regional cooperation bodies. The world is divided to 6 regions. One of them is IAAC, which for the Americans. Then we have APAC. This is the region for Asia Pacific. Then we have EA for the European region. Then we have AFRAC for Africa. Then we have ARAC for the Arab countries. Then we have SADC, it's part of in South Africa. Those are the regions. Five of them, or all of them are recognized, while only one, which is SADC, is in the process. Now it is in the final. Yeah, they report within ILAC just this month. So what's the role of the regions is to evaluate the national accreditation body and to ensure the quality of services provided by the national accreditation body. This is the main role of the regions. So who is evaluating the regions? Evaluating the quality of work provided by the regions. This is the role of ILAC. This is International Laboratory Accreditation Cooperation, and ILAC is the only organization responsible for the accreditation for all kinds of labs, calibration, testing, medical, for inspection body, for proficiency testing providers, reference material producers, and biobanks. This is actually the role of ILAC. If we see at this slide, you will see that we have thousands of conformity assessment body at the bottom, and we have only one organization at the top of this pyramid. So this, the ILAC is the only one responsible to define the criteria for the evaluation of the regions, evaluation of national accreditation body, and to ensure that the national accreditation body provide good services and a good assessment to the conformity assessment body. Actually, once the national accreditation body is evaluated and recognized by ILAC, all national accreditation bodies, they sign what we call it MRA. This MRA agreement, this is multi-recognition arrangement agreement. This is agreement between all recognized accreditation body that we accept the results of each other. We accept, based on those harmonized evaluations, we accept the certificates provided by all the accreditation body in this system. And we also accept the certificates or the results of those conformity assessment bodies, including medical labs and biobanks. This is the main role. And once we accept those results among us, in this case, there is one objective for this system, which by ILAC is called accredited once and accepted everywhere. It means that once a biobank, for example, is accredited, or a medical lab is accredited by national accreditation body, and the national accreditation body is recognized by ILAC based on those peer evaluation, then we accept the results everywhere between the members of ILAC. In the regions, we have 6 regions now. But for how many national accreditation body recognized by ILAC? They are now 109 accreditation bodies, which are already recognized by ILAC. This is the ILAC arrangement coverage. Those in blue, those are the signatories. The signatories are those are evaluated by ILAC, accepted by ILAC, and they sign the what we call it MRA arrangement. We see that Egypt is one of them since 2009. Those are covered by ILAC MRA. Those associate members, those are national accreditation body in the way of evaluation. They are ready for evaluation, but has not been signed the agreement till now. Then we have an affiliated, minor affiliated bodies. Actually, this is the situation. The ILAC network of accreditation body members now include 109 full member, or what we call it MRA signatory. Those are signed the agreement that we accept the results of biobanks, medical labs between each other once they are accredited by a national accreditation body, which is recognized by ILAC. Actually, the MRA of ILAC includes calibration, testing, medical testing, inspection, proficiency testing provision, and reference material production. And finally, just biobank is added to those conformity assessment bodies. This is the accreditation for calibration, testing, medical, inspection body, proficiency testing providers, certified reference material producers, and biobanks is added to them. Actually, those are the standards used, or the criteria for their evaluation, the criteria for the used. 17025 is used for calibration and testing labs, 15189 for medical labs. We have 17020 for inspection, 17043 for proficiency testing providers, and 17034 for reference material producers, and 2387 for the biobanks. This is the update on extension of ILAC MRA to include biobank, because biobank is just added to this MRA in 2021 only. The ILAC arrangement has been recently extended to include the accreditation of biobanks. A resolution was adopted at the ILAC General Assembly in October 2019, noting that the standard applicable to biobank facilities for the purpose of accreditation is ISO 2387, and we agreed at ILAC that this is the appropriate standard for accreditation of biobanks. Further resolution was issued in November 2021, endorsing the recommendation to extend the ILAC MRA to include the accreditation of biobanks. Since that time, the accreditation of bank is under the ILAC MRA. What's the outcome of accreditation? Why we need to accredit biobanks or the other conformity assessment body? Actually, what's accreditation at the beginning? What's meant by accreditation? Accreditation actually means we need to ensure the technical competence. This is the main objective of the accreditation, is to ensure the technical competence of the organization. We are not accrediting methods, we are not accrediting equipment, but we are accrediting organizations. And we need to ensure that the organization is competent. It means all personnel, equipment, environmental condition, and everything is in line with the standard. So this is a third-party attestation. Please look at the wording third party. Third party means this is impartial organization. It needs that the accreditation body to be a third-party one. It needs to be an independent organization. It needs to be not to practice or to provide any of the conformity assessment activities. That's why it's called third party. It doesn't make sense that the accreditation body has a lab, then they accredit laboratories. It doesn't make sense that the accreditation body has or provides proficiency testing schemes, and they are accrediting the proficiency testing provider. That's why it's called third party one. Third party attestation, that the conformity assessment body, which means those conformity assessment, including the biobanks, fulfill specified requirements. Those are the standard requirements, and we will see what are those requirements, and it is competent. This is the key point for accreditation. Key point for accreditation is the competence of the organization to ensure that they are accredited, to carry out specific conformity assessment tasks. We cannot say that biobank is accredited. We cannot say that medical lab is accredited, but what's the specific field in which those organizations are accredited? So this is an important issue to define which is the scope of accreditation and the specific task to be accredited. Why we are going to be accredited? This is the reason for accreditation, or the benefits of accreditation. First thing, accreditation, this is an index or indicator of an organization capability. It means biobank capability provided by impartial third party. This is an important issue, that the accreditation body needs to be impartial one, and it is a third party organization. Normally, accreditation gives confidence in biobank output and international recognition of biobank reports based on the system that I explained to you. Then it creates a framework for greater consistency and reliability of biological material and associated data. It increases the value and reliability in use of biological material and associated data, in research and other application. It assures stakeholders that, crucial requirements are being consistent met. It's an important issue also that accreditation uphold the expectation of the quality in both banked material and biobanking practices. It also provides harmonization with international standards, ensure implementation of health and safety requirements. It reduces the risk in the organization itself. And also, one important issue nowadays is a regulatory domain. The accreditation currently represents a tool utilized by the government administration and organization for authorizing biobank that operate according to relevant regulations. Who are the beneficiaries from accreditation of biobanks? Normally health and population, agriculture, industry, because biobank is not only limited to human samples. It can be human sample, it can be plant, it can be animals. That's why health, population, agriculture, industry, they are benefit from the accreditation. Healthcare organizations, scientific research, and universities, biobanks themselves, they have benefit from accreditation. Patients, regulators, and governments also, they have benefits from the accreditation. There is accreditation principles. It means that we need, what is the principles, or what's the main conditions for the accreditation body to say this is an accreditation body. First thing is governmental delegation, because all the accreditation body under ILAC MRA, they are governmental or delegated by the government. And this is an important issue, that governmental delegations, the competence, and this is an important issue, that the accreditation body is evaluated by the regions to ensure their competence to provide, to accredit the conformity assessment bodies. The independence, impartiality as a third party, this is an important issue, confidentiality of information, and not to carry out conformity assessment activity. As I told you, it doesn't make sense that the accreditation body has a medical lab or has a proficiency testing provider or produce reference material and accredit those organizations. So one important issue is not to carry out any of the conformity assessment activity. And an important issue also that the accreditation body also have international recognition. That's when they provide the services to the market. The results of those conformity assessment body are accepted everywhere based on those systems I explained to you. What's about the accreditation process? I need to give you just quick view about what's accreditation process. Normally, the accreditation process based on EJAC process, it starts normally by document review. Normally, we review the documents of the biobank at the beginning, includes all manual procedures, work instruction, records, everything, key records, everything are reviewed by the assessment team. Then the assessment visit is conducted. The assessment visit normally is the key step or the key stage normally that witnessing is carried out during the assessment. They make interview to the staff. They ensure about the implementation, ensure about the records, ensure about the documents, references they are used, environmental condition, facilities, everything are witnessed during the assessment visit. The assessment visit has only one role. They recommend only accreditation. They didn't have a decision, just recommendation. So the assessment visit, the assessor gives recommendation to another committee, which is called technical committee. The technical committee makes a review to the recommendation and the assessment report. Then the final stage is the decision making. And based on the rules for accreditation, decision-making persons shall not be involved in any of the committee stage or the assessment stage or the document review stage. They need to be independent. That's why the decision is taken independently by decision-making. And the decision-making committee in EJAC, it includes from governmental, from non-governmental, from private service. There is no domination for any of the sectors. Actually, after accreditation, the steps has not been finished because the accreditation body need to ensure that the system is maintained. It's not only enough to give you a certificate that you are accredited, but you need to look at your system regularly based on what we call it accreditation cycle. So in the accreditation cycle, EJAC has 4 years accreditation cycle based on the rules. The 4 years accreditation cycle in this case, it needs 3 surveillance, but based on the new standards for operation of the accreditation body, they give them that 2 assessment, the time between 2 assessments shall not increase 2 years based on the risk. That's why they bought the assessment program based on the risk from the biobank or from the medical labs. Then after the reassessment, there is another period with a new certificate issued by the accreditation body for a new period. Actually, what's accreditation requirements? What's the criteria for accreditation? Normally, the criteria for accreditation are 3 categories. The first one is the ISO standard. ISO standard. This is the first criteria. The second criteria is ILAC requirements. And then the accreditation body requirements. Normally, the ILAC requirements and the accreditation body requirements does not add or subcontract from the main criteria. It gives interpretation to what's included in the ISO standards or just administration requirements. But mainly, it is the ISO standard requirements. For what we will see now, one by one, quickly. What about the ISO standards? For biobanking, 2013-87, this is the criteria and the standard used for general requirements for biobanking. Please, this is not mainly for the accreditation. This is mainly for the biobank itself to implement this one to ensure that they are competent to do their work. So this document specifies the general requirements for the competence, impartiality, and consistent operation of the biobanks. And it is applicable to all organizations performing biobank for research and development. The standard is for use by biobank mainly to develop their management system and assessing their own competence. And also it is used by the accreditation body in conforming or recognizing the competence of the biobanks. The structure, this is the structure of the standard. Quickly, we are not going through them, but the new structures of all ISO standards for the conformity assessment accreditation, they have the same structure. They have general requirements, they have structure requirements, they have resource requirements, and resource normally means personnel, facility, equipment, and those are the resources. Then the process requirement. This is an important process which includes all the process of the biobank, from collection of biological material and data until the reporting and sampling, and all those processes are included in the process requirements. There is no time to go through all the process requirements. Then we have quality management system requirements. Those include control of documents, control of records, action to address risk and opportunity, and also improvement, corrective action, internal audit, and management review. Then we have another document. This document, which is ISO, this is a technical report. It is not a standard with requirements. This is 22758, 2020, and this document is intended to be a supplemental rather than a substitute for 20387. This is not a standalone document. It is used as interpretation document for the standard itself. And it is a technical report, and it includes informative. It is informative document, or it includes information, and there is no requirements. Then this is the ISO standard. Then the second requirement is the ILAC documents. ILAC, mainly we will have 3 main documents. One of them is ILAC B9. ILAC B9, which is now under revision. This is the policy for participation in proficiency testing activity. This is applicable to biobanks, medical lab, calibration lab, testing labs, and an inspection body. We have also ILAC B10, which ILAC policy and metrological traceability of measurement results. And this is how to calibrate our equipment. How are the equipments are calibrated? And what are the rules for calibration of equipment? This is in B10, and it's applicable also to Biobank. The last one, which is G24, this is issued just 2 weeks ago. It is in December, or 3 weeks ago. It was published in December 2022. This is guidelines for determination of recalibration interval of measuring equipment. The problem for all biobank people or for medical labs or calibration testing labs is at what time I calibrate my equipment. What is the period for calibration? What is the due date of calibration? This guidance documents is a helpful document. You can go through this one to ensure how can I determine the due date for calibration. The accreditation body requirements just a publication and guidance for implementation of the ISO standard and ILAC requirements and for clarification of the accreditation process issue. Those are the requirements. How do you prepare yourself for accreditation? This is quickly, I will go quickly, that you need to, first of all, where are the staff? What's the responsibility of the staff? So you need to identify who are the staff working with you in this biobank. Establish a staff role, appoint quality manager, technical manager, whatever the names. The standard does not have any restriction to names or whatever. Just this is from practicing. We call quality manager or technical manager, or who are responsible for the technical issues. Educate yourself on the standard. This is an important issue. Then identify and implement applicable reference documents for biobank. You have a lot of documents for risk management, documents for validation, for verification, for sampling, for whatever the documents or the reference documents. Then create your management system. Start with the policy. The policy includes just a policy of the biobank. Then quality manual. I understand that the standard does not require quality manual, but normally from practice it includes reference to all management system documentation. Then you need to implement your instructions, procedure, drawing, plans, schedules, records, whatever those are the management system documentation. Then perform internal audit. This is an important issue that you need to prepare some people with you to make an internal audit. This internal to verify compliance with the requirements. Then an important issue also to carry out management review by the top management to ensure the compliance according to the standard requirements. This is, I finalized those things. Just I will give you a conclusion. Now, first thing is accreditation of biobank to ISO 20387 involve an independent, unbiased assessment of the biobanking facility to determine competence, impartiality, and consistent operation. Biobank accreditation is the internationally accepted framework for increasing process quality and reducing biobank risk. Based on the system that I explained before, that once you are accredited by recognized accreditation body, in this case, your results will be recognized internationally. All parties should make accreditation public biobanks. This is an important issue for public biobanks. A high priority, it needs a high priority for public biobank. And should undertake coordinated efforts to integrate accreditation programs into their policy. This is an important issue to be accredited, and planning including health system strengthening initiatives. The last thing is the process of accreditation is the same by internationally recognized accreditation body, including JAC. JAC has been recognized by ILAC since 2009. I understand that we have a limited time, so I try to give you an overview, quick overview about the whole process. I understand that there is no time now for questions and discussions, and it will be at the end of the session. So thank you so much, and at the end, if you have any questions, thank you.
Thank you, Engineer Mahmoud Taib, for this excellent orientation about the JAC and ISO 2387.
Our next speaker will be Dr. Ahmed Khalifa. He's talking about the insights of CAP biobanking accreditation. Welcome, Dr. Ahmed.
Thank you. السلام عليكم جميعا. Assalamu alaikum جميعا. First, I would like to thank you, Engineer Mahmoud, for your comprehensive and very valuable, informative presentation. And if you allow me, I can start with some points which you mentioned to start my presentation. As you mentioned here, accreditation value for any biobank, either we are working in research for clinical purposes, for forensic, for whatever the purpose for this biobank, we need to have a quality management plan. And this is actually what we are going to start discussing today. Quality management plan and how to settle in our laboratory. We have briefed about how is the inspector, how is the accreditation body is looking for the organization. However, what we have to do in our laboratory inside, how to prepare ourselves to be ready for the assessment, and how to maintain the quality for the surveillance and the reassessment, which is maintaining what we have achieved in quality is much difficult in compare with the first step. Quality management plan has a criteria. It should be dynamic. It should be consistent. It should be monitored. It should be with continuous improvement indicators, review, assist, implement, share with the team. This is very important for any organization. Either we are talking about blood bank, biobank, laboratory, medical laboratory, research laboratory, wherever we are. And I'm sure Engineer Mahmoud can agree with me that we can even implement this in industry or any other sectors rather than the medical. In our laboratories, in our biobank, do we have a template for that to implement it? The answer is no, we don't have. We don't have a specific format for biobanking quality management plan or quality management system. We have to build it ourselves. It depends on our scope. It depends on our space or area we are working in. Are we a research lab? Are we a clinical lab? Are we a forensic? It depends. Are we a university? It depends. But for sure, there are a lot of resources we can use it. For example, the CLSI guidelines, how to implement based on that. For example, the ISO system for 9000 for documentation and preparing everything and building our quality management. For example, the CAP Biorepository accreditation program. It provides a lot of information during the checklists when we go through it. For example, the 15189 from the ISO. All of those are providing us a lot of references to follow. To start, what is the key elements which we need to understand and to build our quality management plan based on? Number one, the documentation for the quality management. Number two, it should be written, covering all the areas of the biorepository or the biobank steps. Number 3, what is the relevant information which we need? What is the science behind? Data. We have a lot of data coming through the whole processes. Is this data analyzed? Is this data shared, improved for the consistency of the site? All of these processes, we will go in deeply after that. What is the opportunity for improvement? Based on the data analysis, we need to go for risk assessment, putting our corrective action plans, preventive action plans. So this is the improvement which is continuous for the surveillance, as Engineer Mahmoud mentioned before. We need to implement what we agreed upon. We need to implement the assessment, or the inspector, when he comes to our place, he's not asking only for what is your documents, what is your SOPs. He needs to discuss it with you. And he needs to be sure, which is a very important step, that you are complying with those requirements and these standards. How can he make sure that you are complying? You need to provide him with a proof of evidence that you are complying, with records. He's looking for that. He will not read your documents. He will not read your SOPs, your forms. He needs to check that you are complying and you are competent enough to have the certificate. How can we develop it? First step is to define our purpose. Is this biobank only for research? Is it for clinical? Is it for forensic, or whatever the other types? Also the sample types which we are using, because it depends also on what we are going to plan after that. Develop the necessary structure. What is our organization structure? What is the required infrastructure? We need how many deep freezers we need, how many, whatever space needed, the staff, all the resources needed, we need to settle. The third topic is the scope. What we are going to do. We need to define what we need to do and what is the impact of that. How to implement. And the implementation processes itself, it has to be planned. And planning here, we should have tasks. Everybody should be engaged from our team, and timely mannered, or as we call it, tasks are clear, measurable for the performance of the team. So we have our plan for implementation successfully achievable. After implementation, and during even the implementation, we need to evaluating our team performance, evaluating the steps related to the project, if we call it a project for our accreditation journey, for example. And after that, we need to review and we need to revise, because during our journey, we will find a lot of mistakes. And this is very natural everywhere. We need to define what we are doing good, what we are doing improperly, and we need to revise it and implement it, reassess, monitor, and review and revise. It's a huge circle for the whole life of this place. This is why we are calling the quality, it's a real journey. It will not stop. Including the process and functions. For examples, I'm going to give you some examples about what we need to discuss, what we need to consider during our processes for building our quality management plan. First, if we start with the sample, our samples, which is our valuable product, let me say. Sample collection. how we collect it, what we need, what we should implement, how can we monitor. All of these steps we will come later and discuss. Handling, how we receive it, how we put the labeling, the accessioning, entering the data, everything. This should be part from our QMB plan. Processing for the sample, extraction, whatever, storage, everything. Inventory tracking or inventory management system, whatever we call it, we should have it in place. In some places we can have it electronically or automated, we can have it manual, but if we have it manual, we need to have a very confident and secured data controlled. Sample data distribution. After that, what is the impact of the data which we have in this biobank? Are we use it for research? Are we use it for clinically impact or something? Is it for forensic purposes, for example? So these data, how can we distribute it? What is the confidentiality levels? We need to define the confidentiality level for data distribution. Our information system, which should be secured, for example, how is the data entry? We have it. And who can access this data? For sure, we should have access level for our team. Safety practices, safety standards, health and safety, biosafety, everything should be clear here. Documents control. This is very important part. How can we find our documents? How can we arrange it? How can we link it together? This is the document control system we need to build. Equipment maintenance, for example. We have deep freezers, we need to control the temperature, we need to revise it in case of if we have any incidents, how can we check this? We need to build our system covering all those steps. Review the incidents, make the corrective actions, monitor the corrective actions, and put this as the preventive actions. Monitor, reassess, train your team. All of these steps should be considered when you are building a plan. When you are doing the review, you have to consider the workflow. We are in a technology which is every day there is a changes. There is multiple purposes we might implement in the same place. So we have to consider the concepts for Lean and Six Sigmas to reduce the errors and minimize the error as much as we can and control the risk. Customer or researcher focus. We are providing this service for whom? Is it for the patient? Is it for the university doctors or professors, for some research? Is it for example, for forensic purposes, for Ministry of Interior, for example? Who's the customer? And what is the customer satisfaction level? We need to check it. And we need to assure that we have a certain defined or predefined level of customer satisfaction. To control all the steps, one important thing we need to have, which is the indicators, the monitors. A lot of confusion comes in this area when we are defining let me say, some people say it's a KPIs. Some people say this is the monitors, this is the indicators, whatever we call it, but we need something measurable to define how we are meeting the quality initiatives which we settled before. We have targets, and these targets need to be measured. Are we on the plan or not? This is in a very simple way. So, how we select the indicators? A lot of people comes and confused because the indicator which we are using in the medical laboratory might be different than the indicators we are using in a research lab. The indicators we are using in biobank for clinical purposes might be different than the one for the forensic one, for example. So we need to define, based on our scope, what we need in this area. Any monitor or indicator we need to define has to be measurable. How we measure it, how we track it. This is very important point. And for sure, it should be actionable or realistic that we can achieve. I cannot claim that I need 1 or 2% errors in the accessioning of samples. Is that achievable? And when it comes to the KPI, when I monitor it, I found it 50% or 40%. So I need to be realistic and be patient to improve and reassess and review to reach a reasonable, let me say, best practice or the standards globally. For example, this is our target, but I'm not claiming that I need it 100%. Quality monitors. For example, if we can talk about the incidents, all biorepositories, you need to monitor all the relative incidents which are happening in your biobank. And once you monitor, again, you need to report, you need to make the root cause analysis, you need to set your action plan for recovery, corrective action, protective action, which is might be training my team, sharing some information with the customer or the people who are providing the samples or whatever, and we will come for a written example for that later. Now I will go step by step for the whole journey. Now we have a biobank, okay? How can we start step by step with our first asset, which is the sample? Starting with the sample and the kits we are using. Kits coming from a company, this company is for sure should maintaining acceptable level of quality assurance systems they have. As for example, for ISO certification for manufacturing, the reference material, or for whatever, for the kits, CE, FDA approved kits. So first step that we are assuring the quality of materials we are using. Number two, coming, which is the consent form. We are dealing with highly confidential personal data, which we need a consent form from the customer, also for how we use their samples, especially when it comes to research purposes. Collection protocol, how we can collect the samples, who can collect the samples, how he can collect the sample, collect it from where. All these steps should be clarified, should be written. Appropriate specimen containers. What is the containers we are using? Is it having a preservative material if needed or not? Everything should be written according to type of samples and according to our scope of service. Specimen labeling. How it should be labeled. The label should be unique to avoid any misleading data or displacement, for example. Collection time, when it collected, by whom? What is the fixation time? What is the cold chain requirements which we need for transportation, for example? Is it for research or not? We have to define this when we are labeling our sample containers. Coming to our biobank. Can we accept it? Can we reject it? Based on what? We need to settle the criteria for rejection. Specimen accessioning, as we mentioned, how we enter the data and what we need it to be in this data. Storage, next step. to store our samples. What is the right temperature we need to store? How we monitor deviations in case of any incidents. What is the corrective actions should be reported? What is the monitoring time plan or calendar or whatever we call it? What is the threshold for acceptability or rejection or escalation in such cases when we have a problem with the storage? Is there any electronic alarms for the place or not? All those steps should be considered either from the general infrastructure requirements or from the documentation and monitoring processes. Inventory tracking system. Accuracy of the system should be checked. Any IT solution, by the way, in our organization should be checked for the capacity of it, for the liability or realistic acceptance for our IT solution and the tools we are using. We need to have a periodic audit for the performance of the system also. For the samples, we can have random check for certain places, what is the sample exactly following the tracking of the data and the records which we have. We have to follow all of this. Quality control, proficiency testing, everything should be controlled, should be documented, should be verified. Are we on track or not? The histology samples, the quality of the histology samples which you are receiving should be checked. Equipments, we are using everything in this laboratory should be checked. We have to look for the temperature control for the deep freezers, for example. We have to look for the temperature at the place because this is also for our team. We need to look for the safety of our employees. What is the safety measures? What is, for example, the backup for emergency for electricity? All of those stuff should be managed, should be controlled, monitored, and also reviewed periodically. Clinical errors. One of the most, let me say 60-70% of the errors happen in any healthcare facility. Such biobanks, such laboratories, this is the main error which we are facing when we are reviewing the type of errors. Sample distribution. Also for sample distribution, we need to review the shipping methods. We need to write it down, how we are going to ship, what is the track, how we pack it, how we send it, how we control the temperature. Distribution also should be attached with a consent, and this is very important in a case of biobank. Who can sign and who will sign when he is receiving the sample for distribution. And the final one in our processes, again, we are coming to our customer. Is our customer satisfied or not? We need also to have a satisfaction survey, let me say, annually. It depends on the organization, how can we settle and how we need it. And we need to measure the customer satisfaction level and working for improvement and development. Our personnel. The other important asset in our place, in our organization, our team. Our team here need to be trained, need to be competent, and their competence should be assessed. To do the assessment and the continuous training and development is very important. We need to have a plan for that. and timely mannered reassessment and evaluation for our team, focusing on the quality perspectives, technical perspectives, and even the behavioral perspectives. Safety of our employees is very important. Safety, what they are doing exactly in their daily practice, we have to focus on. Data management. As we mentioned before, we are dealing with some level of high security and confidentiality for the data, so we need to define who can manage this. The data security for our system, if we are using some PCs, for example, with manual work, or we are using an automated solution for our organization. So everything, we should assure the security and confidentiality for the data. Documentation for the procedures also should be. The IT solution or the tool which we are using also should be tested to assure they are coping with our workload, for example. Some other topics which we need to focus on also, I put it here under miscellaneous, which is the quality indicator for the effectiveness. How effective is our organization? To what extent we are effective? The corrective action and preventive action implementation and follow-up and tracking. How can we measure the effectiveness of the corrective actions we have taken or we have settled, have been implemented or not? Our audit program, when, on what, and how, we need to have everything planned. Customer service and satisfaction also, again. As per best practices, for example, related to the ISO, if there is any updates, we need to update our programs. Self-assessment tools, there is a lot for the biobank. We can find it and use it. Risk mitigation. Again, we are coming for evaluation of the whole processes which we have. How can we evaluate it?
From the
The evaluation should be measurable. Define the
Public
outcomes
Health Agency of
which we are observing with our team,
Canada,
based on
which ended in
participating in
2015.
the processes, having the tools to obtain all the informations which we need. Sometimes we don't have the tool exactly to implement on the place, so we cannot measure or monitor our performance. We are getting data. Is this data analyzed? This is very important. And how can we analyze it? We can use the statistics. There is a lot of tools for that. We can make some graphs and present it. We can make a root cause analysis to understand what is, and there is a different techniques for that. We have the data. We need to share it. I cannot put it on my desk or keep it on my computer. We need to share it with the team first. We need to settle the corrective action plan. Also, timetables should be met. This is example for a quarterly meeting review, which is discussing a certain incident. This is an example. Within this example, how to settle this meeting? First, we need to settle the goal. What is the objective of this meeting? So, based on the SOP number X, we have this meeting for the goal of 1, 2, 3. This is the first step. What is the acceptance threshold? Acceptance threshold here is to have unacceptable shipment, in this example, with less than 25%. we did the investigation for the incidents, and we found 2 topics during this meeting which have been raised, for example, by the supervisor or whoever assigned for this task. He found that during the evaluation period of 2 boxes received from customer, and according to the shipping market here, shipping manifest, it should contain 25 samples each. However, he found 15 inside. So this is the incidents which he reported. The second incident, which is during the evaluation period also, another box coming from another customer, received on Saturday, including 50 samples. The samples, when they come and check it on Monday, it's not in a proper situation. It's partially sewn, not freeze, on the required temperature. First, we need to discuss who, because we have the data, what is the mistake happened, and why, who sent it, who transported, then settle the corrective action, which should include, number 1 is training our staff. Training the customer people, if they are the people who are sending the samples. We need to check this, and we need to train them. It's our role also. Second point is monitor this behavior, if it's going to happen before, and what is the acceptable percentage for that. Is it continue within the same level, or we need to have extra root cause analysis to assure it's within our criteria, which is the 25%. Finally, we need to define the indicators, put it within a calendar. We settle the thresholds, change in practice if needed, and monitor the outcomes. Finally, have a communication plan, share it, and make sure that we are on track for the continuous journey of quality management. Thank you. I think we are on time, or a little bit late. Thank you very much.
Thank you, Dr. Ahmed, for the nice and comprehensive presentation about the process. Our next speaker is Dr. Ayat Salman. She's a colleague from Canada. She will present, it will be virtual. The presentation is the Canadian Primary Care Sentinel Surveillance Network. The Canadian experience of an electronic medical records based data repository. Welcome, Dr. Ayat.
Hello, everyone, and thank you for giving me the opportunity to present the Canadian Primary Care Sentinel Surveillance Network, the Canadian experience of an electronic medical records-based repository. Before I start the presentation, I would like to acknowledge the land Queen's University is situated on the traditional Anishinaabe and Haudenosaunee territory. To acknowledge this traditional territory is to recognize its longer history, one predating the establishment of the earliest European colonies. It is also to acknowledge this territory's significance for the indigenous peoples who lived and continue to live upon it, people whose practices and spiritualities were tied to the land and continue to develop in relationship to their territory and its other inhabitants today. The Kingston Indigenous community continues to reflect the area's Anishinaabe and Haudenosaunee roots. There is also a significant Métis community, and there are First Peoples from the other nations across Turtle Island present here today. Primary care teams and researchers are working together to answer important questions and improve quality of care by translating research into practice. This is a study that's been conducted 20 years ago, and is still relevant today, where we noticed that only 1%, less than 1% of the population is actually followed in a tertiary care setting, whereas of the population is followed in a primary care setting, where all of the money and research has been focused a lot in tertiary care. We tend to forget what is happening in a primary care setting. And this is where the idea this is where in primary care in North America, we've been slowly trying to build infrastructure in the forms of what we call practice-based research and learning networks to address important questions and improve quality of care by translating research into practice. So what is CPCSN? CPCSN currently is a data repository, EMR-based electronic medical record. It has more than 2 million Canadian patients in the actually right now at the data repository. It includes more than 800 practices across the country. We represent actually 14 to 16 primary care-based research and learning networks, representing 8 provinces and 1 territory. I do mention here 14 to 16 because we do have 2 new networks that have been added up, one in Saskatchewan and one in the Northwest Territories, as well as a new practice-based research network located with the Canadian Correctional Services. So we are following up incarcerated patients who are being followed by primary care physicians in Canada. This is a project that started back in 2008. It has received more than $12.5 million in funding, specifically from the Public Health Agency of Canada, which ended in 2015, and certainly the project now that started as a surveillance for chronic disease has now turned into more of a data repository. And obviously, it is actually a collaboration of multiple universities across the nation. But core operations of CPCSN is located in Kingston and in Queen's University in Ontario. So what constitutes CPCSN? CPCSN, like I said, is 12 to 14 practice-based research and learning networks. And a lot of, you will see that there are a number of PBRLNs representing Ontario, and this is important because right now Ontario has developed their own data repository representing Ontario, and that would be under the new network called Poplar. Like I mentioned before, it is really a collaboration of a number of universities across the nation that came together to build that data repositories that started back from surveillance of chronic disease that has now moved to a repository. So what does CPCSN do? CPCSN creates a standardized, high-quality, cleaned, coded, and de-identified primary care data. So it's EMR data coming from those practice-based research and learning networks. Those PBRLNs are a combination of different physicians, clinics that work together and that form a network. So the data is coming from multiple practices that have all collaborated together to create a network. And CPCSN here really acts as a data steward for the Pan-Canadian primary care electronic medical record data. The data is accessible to researchers outside of the CPCSN network. It is accessed through our secure research environment, which has been created at the Royal Military College of Canada, based on a postdoc researcher who was interested in creating an environment to access data securely, and that environment was actually donated actually to CPCSN. And we've developed that environment so that researchers have access to the data through the environment. I will be discussing more into details of what is the basis of this environment and some of the background of it. CIBSID has also a general governance structure, an advisory board that is represented by various stakeholders external to CIBSID. The steering committee represents the network directors as well as members of the executive management. The executive management, which was what we call core operations, is the team that manages day-to-day CIBSID work. And of course, CIBSID has the different committees. The Data Access Committee that actually reviews the access requests to data, as well as protocols, and specific data governance for our First Nations, Inuits and Métis, where we talk more about data sovereignty these days and not much of data governance, and as well as the Data Governance Committee, who ensures that we follow provincial and federal laws as things do change in terms of policies provincially and also sometimes on a federal level. As I mentioned before, CIBSID is really pan-Canadian. It represents the nation, but Poplar has also is also a network that's been created specifically in Ontario, because Ontario already hosts about 9 of the networks that are 9 of the 14 to 16 networks that are represented in CIBSID. But we are working collaboratively to ensure that the data extracted at Poplar is actually transferred into CIBSID data repository. So how do we incite physicians or clinical primary care clinical centers to actually come on board as custodians of the data of their patients' data and to participate in CIBSID? So we do give back to our physicians. We give them back through a presentation tool through a dashboard. It basically, the dashboard presents to the different physicians some of their data that they're interested in. For example, how many visits they've had, how many conditions have they seen in the past month. They are customized reports that we give back to our physicians in our clinics at the individual level, but also at the clinical level. So it's an overview of what is happening at their clinics. So this is a way of giving back to our physicians who participate in CIBSID, and that we ask a lot every 3 months from them to actually work with us so that we get into our what we call extraction windows. So that's a way of giving back to them. So what type of data does CIBSID hold? Data holds patients' sociodemographics, a number of encounters, the diagnosis, medications. Basically, the EMR chart of each patient is actually extracted, and the exception of medical notes and PDFs. The reason is that we work with different EMR providers, and PDFs have not been in their in the works of being extracted because it takes too much space during the extractions. But this is something that is coming up through our new automation process in June, where PDFs will be included in our in the CIBSID schema, and where data will be extracted from the PDFs and recoded in this CIBSID schematic. We do have also some data quality assurance that we do. So what do we do with the data? So we clean the data. So the data is extracted from EMR, it is received on the Simpson side, it is cleaned and then recoded in SQL language. So I'll give you an example of the type of data that we extract. So as you can see in this example, we see the medication amitriptyline in different ways, written in different ways, written in with different dosages. So this is the type of cleaning that we do to ensure that we have standardized data once the data is received on the Simpson side. Another example to show you the percentage of codes, so of data points. So if you look at, for example, health conditions, you can say that we have 52% of the data points are actually available in our extraction before the cleaning, but right after the cleaning, once we go through the process that we have, we realize really that we have 60% of the data point. So there is a good cleaning that is done to ensure that we maximize the data that is available, and to ensure that the data points that we're interested in are actually available in there in the EMR once it's cleaned. So where is this data going? So each network is led by a network director as well as a data manager. The extractions happen 4 times a year. So every about 3 months, there's an extraction that is happening. Each network will extract their own data, will clean it up based on standardized Simpson coding. Once the data is cleaned and coded, the data is sent centrally at Queen's at the Center of Advanced Computing. Obviously, the data is sent through virtual private networks and firewalls. It's only accessed by the data managers specific to their own networks. Once the data is ready and cleaned up, it is actually transferred into the centralized server at Queen's, which is the server that represents the Canadian pan-Canadian data repository. So the Center of Advanced Computing at Queen's is a secure data center that is compliant, of course, with all local and national security and privacy legislations. The servers are isolated physically and as well as virtually from the rest of the data center. It is also accessed through virtual private networks, and the secure research environment is also hosted on separate hardware, also at the Center of Advanced Computing. This gives you an overview of how the extraction, how the data is flowing. So we work with close to between 4 and 5 different EMR systems where we have providers, we have contracts with providers that actually go into their system to give access, that where the data is extracted, it is sent to our data managers, and the data managers move forward to start with the cleaning process. Once it's cleaned and transformed and coded, it is actually sent securely to the Center of Advanced Computing. In the Center of Advanced Computing, we actually merge databases together, and then we customize data sets and reports, and we give back the feedback reports, etc., as I presented previously. And then we develop custom data sets based on researchers' requests. This is another overview of how the data is processed, and how it's transformed, and who really has access to the data. Extractions were done previously twice a year. Now extractions are actually done 4 times a year. And this gives you a data life cycle overview of what happens when we have a researcher accessing and requesting the data. So as I said before, the data is stored and managed using a relational database containing multiple tables. It's SQL based language. And it basically allows multiple tables to be linked together and into a single result set, and they're linked by key fields. And the data is accessed through the secure research environment, also in SQL, through an SQL process. And researchers have access to the secure research environment, where all the analytical tools are available for them to analyze the data based on their research protocols. CIBSEN has also developed a data access process where requesters fill out a data access request form that is available online. They can actually also use the data dictionary or the data catalog that is also available online to give them an idea what type of data points are available and variables that are available. The process is very similar to the biorepository access. The major difference is that there is no data transferred outside of the CIBSEN network. The data is actually accessed through the secure research environment, which is kind of like a virtual private network machine, where the requester has access to that virtual machine from their computer, where they can analyze the data. All the analytical tools are actually available in the front end. Once the researcher has finished analyzing the data and has the file output, an internal CIBSEN reviewer, usually a privacy officer, will review the output just to ensure that this is exactly in compliance to the protocol that was reviewed and approved for, before the file is actually transferred out to the requester or the researcher. Again, there is no data going outside of the CIBSEN network. Everything is done within the virtual network, virtual private network of CIBSEN. The only thing coming out is the actual analysis output. So this slide presents to you the secure research environment architecture. In our environment, there are 2 zones. Zone A, which is admin accessed only. There is internet connection, there is a way of copying and pasting, etc. And then there's a zone B. The zone B is actually a secure environment, where the front end for the researcher is a Microsoft Office, Microsoft front end with Microsoft Office tools, as well as any other analytical tool that the researcher has requested. And there is no connectivity with any internet or any other type of connections happening in Zone B. It is again one machine that is actually physically located in the Center of Advanced Computing. So as mentioned before, this is the front end for the users. It's familiar Windows desktop experience. interface. They get remote access via the remote desktop, Microsoft Remote Desktop protocol. All the analytical tools are included as part of the access services, SAS, Python, and R Studios. Since its inception in 2008, CIBSIN has evolved a lot. We've created machine learning algorithms. Data has been used for more than 100 projects across the nations, and we've had numerous peer-reviewed publications based on data access through CIBSIN. As we move towards more automation when it comes to extractions with our EMR vendors, especially with fire automation, our processes are getting upgraded based on the technology that's coming up. As I mentioned before, as PDFs are now going to be included in our extractions, we have also developed our coding processes to extract information from PDFs and be able to code those variables and this information that's extracted from PDFs and put them in SQL language. And of course, that would not be possible without all the network directors, as well as their data managers and research assistants, and especially the day-to-day operations led by this amazing team, our two co-chairs, Dr. Wong, Dr. Barber, our data analyst, and of course our admin officer. I want to thank all our funders, our stakeholders, our partners, and also our physicians who voluntarily participate into CIBSIN and who have collaborated very much all these years in creating the tool that we currently have as CIBSIN. And of course, I want to thank the organizers of this conference for inviting me and giving me the opportunity to present the Canadian experience and perspective of building a data in EMR data repository. Thank you.
Thank you, Dr. Ayat, for this comprehensive and successful multi-institute collaboration, and as an example of data sharing between biobanks. The biobank is not only sample, but it's include data and a clear process for accessing and sharing the data. I think we will have the questions at the end of the session. So our next speaker will be Dr. Marianne. Dr. Marianne her talk will be lightning talk, qualification in biorepository science, QBRS. Welcome, Dr. Marianne from USA. Hello, Marianne, can you, okay, can you put in presentation mode and view mode? I cannot see you, yeah. Now it's coming, thank you.
Hello, my name is Mary Ann Henderson. I work at the U.S. National Cancer Institute, and I am a former ISBR president. I thank you for the invitation to tell you all about the qualification in biorepository science exam that ISBR created with ASCP. I'm giving this presentation on behalf of the chair of the QBRS Steering Committee, Brent Schachter. ISBR, the International Society for Biologic and Environmental Repositories, advances the expertise and quality of biorepositories and biobanking science worldwide. We do this through education and forums and webinars, and also this new QBRS program. The vision of ISBR is to be the leading network in the global biobanking and biorepository community, of which you are a part. In my talk today, these are the things that I will cover. The rationale for the development of the QBRS exam, the application process and resources available, the requirements for exam application. There are 6 different routes that you can go that are the background that you have to be able to take the exam. The scope of the exam, the process and the details, the advantage of the program and the credential, and any questions you might have. ISBR and the American Society for Clinical Pathology, its board of certification, they joined forces to create an exam for biobanking professionals. The qualification is designated QBRS, the qualification in biorepository science. Although there are some training programs for biobanking around the world, including and amongst others the CEDARNet program in Canada, Lund University, IBBL's program.
معلش excuses بس عملنا holding الماريان for just 1 minute. We will announce على الميتنج of the National Egyptian Bioinformatics Network هتبقى هنا after we end up with this session. Thank you.
Yes, please,
In
Marianne,
Luxembourg,
continue. Yeah.
the Medical University of Graz in Austria, the University of Côte d'Azur in France, as well as the program that was established within Egypt. Modern biobanking is a complex activity, as we all know, and it requires highly trained and skilled staff. Well-trained staff are essential to be able to meet the needs of precision medicine, biomarker development, and biomedical research as a whole. Prior to the QBRS exam, no formal certification or qualification existed to define the level of training required to ensure quality in technical biobanking skills. Following detailed discussions between ISBR and ASCP, the Board of Certification, between 2015 and November 2017, as well as discussions around the biobanking community around the world, an MOU to develop the QBRS was signed in November 2017. An exam work group was created with experienced biobankers to develop the scope and structure of the exam. The working group members have expertise in biobanking, and they are from a wide array of countries around the world with different expertise in biobanking to be able to support the development of the QBRS certification. So from 2015 to 2017, a discovery of what was needed to be included in the exam was done, and the agreement was made to create the exam. The work group members are responsible to define the skills needed of a quality biobanker. So they needed to come from a diverse background in biobanking. They looked at job task analyses and created sets of qualifications needed to be able to biobank. They created and updated exam content guidelines. They created eligibility requirements called the roots, and I'll discuss this later. And they also created forms to be able to document the different candidates' expertise, to note that they were qualified to be able to take this certification. As I noted, the work group that developed the exam consists of 8 members, and they were chosen because of their professional diversity, as well as their geographical diversity of where they worked in biobanking around the world. This group was proposed to the leadership of ISBER and the ASCP Board of Certification and governors to be able to provide the governance of this program. Each of the members of the work group are on the group for 3 years, and this term can be renewed. There is annual oversight of the QBRS exam work group by a steering committee of ISBER members from the Standards Committee and from ASCP's Board of Certification. The broad oversight activities of this steering committee make sure that there are appropriate background in standards development. So that is why the Standards Committee is involved. And it also has the representation of the Executive Director of the Board of Certification of the ASCP. The exam working group developed the documentation to apply for the QBRS exam, the exam content, and how they would award a certification. These processes were overseen by the QBRS Steering Committee. From December 2018 through January 2020, the exam was developed and was released to the biobanking community to start applying in April 2020. By the end of September 2022, so far 61 certificates have been awarded. The initial applications were from North America and the certifications, but the certificate program is also starting to be applied for and awarded to biobankers around the world. I hope that by next year, several Egyptian biobankers will also have taken this certification. On the QBRS websites, they list several resources. These resources are of different types. One is to understand how to apply for the certification, and also the requirements for eligibility and how to determine what route you would be on to be eligible. There are also a lot of resources associated with the topics that are part of the exam and readings associated with exam preparation, such as journals, texts, online materials, and the Essentials of Biobanking course on the ISBER website. There is a frequently asked questions document that is particularly valuable as a potential applicant learns about the exam, because other people have asked questions before them, so you can learn from their questions. And then, of course, the procedures for the examination and qualification are on the ASCP BOC website. The details for the application process are on the ISBER.org qualifications website, as well as the ASCP.org Board of Certification QBRS site. Now let's talk about the different ways to be eligible to be able to take the QBRS exam. I'll go bit by bit through the 6 different routes of eligibility. Generally speaking, there are requirements prior to the application that include both academic and work experience in biobanking. I will walk through the 6 possible eligibility routes that have been established for the exam. The first route is you could be a technologist through ASCP. With that, you would also have to have a bachelor's degree, a baccalaureate degree from a U.S. or non-U.S. regionally accredited university or college with a major in biology, chemistry, biotechnology, or some other biology-related field, plus 1 year of full-time acceptable experience in a biorepository within the last 5 years. So Route 1 has all 3 of these requirements for eligibility. The second way to be eligible to be able to take the QBRS exam includes Route 2. Route 2 is that you have a baccalaureate degree in some biological sciences from an accredited university, and you have 2 years of full-time acceptable experience in a repository within the last 5 years. The third route to eligibility to take the exam is having a master's degree or a PhD from a U.S. or non-U.S. regionally accredited university or college in biology or a related field, and only 1 year of full-time acceptable experience in a biorepository within the last 5 years. The fourth route to eligibility to take the ASCP QBRS exam is to be a valid ASCP technician and also have an associate's degree. That is a 2-year diploma program from a U.S. or non-U.S. regionally accredited university or college, or you could be having 60 semester hours of academic credit from one of these accredited universities or college that include 12 semester hours of biology or chemistry or related fields. You also have to have 2 years of full-time acceptable experience in a repository within the last 5 years. And Route 5, the 5th way to become eligible to take the QBRS exam, is to have an associate's degree, or what we call a 2-year diploma, or the 60 semester hours with 12 hours within biology and chemistry, plus 3 years of full-time acceptable experience in a biorepository within the last 6 years. And the sixth and last way to become eligible to take the QBRS exam is Route 6. Having a high school graduation certificate or the equivalent, and having worked full-time for 5 years in a biorepository within the last 10 years. So there are 6 different ways to become eligible for taking the QBRS exam. Here is a summary table of the 6 different routes toward qualifying to be able to take the QBRS certification exam. More details are available on the 2 QBRS websites. And of course, that includes the fact document as well as different resources to be able to prepare you to take the examination. All of this should be looked at prior to applying for the examination. Here is the list of biorepository experience that are required. A candidate should be experienced in at least 4 of these 9 areas listed here. These are all areas within the continuum of biobanking, including subject consent, collection, de-identification, processing, storage, distribution, quality control of the samples and data, or equipment quality control, or enhanced technical areas such as nucleic acid or protein extraction, histology, microarray, tissue imaging, slide imaging, microdissection, viable cell isolation. All of these are in these enhanced technical areas. The scope of the QBRS examination includes the major content areas within biorepository science, such as specimen handling, sample and data inventory, management and quality control, safety and infection control, and biorepository operations. The website can provide more details on all of these areas. Each of these topic areas are 25 to 30% of the exam, with fewer questions on biorepository operations. In the exam, there are 50 questions. Some of these questions are process questions, and some are theoretical. Once you have applied to take the test and have qualified, you have 60 days to take the exam. It is a 50-question multiple choice test that you have 90 minutes to take. So you can take it anywhere you are around the world. The cost of the test is $240 US. I do know that ISBER has offered scholarships to low and middle income scientists. So I assume this is going to continue annually. The exam may be reattempted up to 5 times if the first exam is not successful. And every 3 years, certificate holders have to revalidate their qualifications with documentation of continuing education. More details are available on the website. Here are some comments from QBRS certificate holders. There is also video testimonials on both of the websites as noted. This credential program will be an essential piece in establishing the future of sustainable quality biobanking, harmonizing knowledge across biobanks around the world. The QBRS designation, this certification, helps a biobanker establish their qualifications as a quality biorepository scientist and will become the standard which defines the required level of quality in biobankers. The QBRS designation will be an objective indicator of the value of a certified biobanker in a quality biorepository. Here are the websites for frequently asked questions. If you need more details, please go see these two websites that mostly mirror themselves, but they're from the two organizations involved in the program. If you have any questions, again, you can look at the two websites. You can email Dr. Schachter or email me at these addresses. I'm happy to answer any questions you have. Thank you for listening to the details of the Qualification in Biorepository Science examination. I hope that by next year, you will be QBRS certified as a quality biobanker. Thank you.
Thank you very much, Mr. Henderson. Dr. Henderson, thank you very much. The question will be at the end of the session. You will be with us. And now, it's my pleasure to introduce Dr. Ayman Al-Khayyat. He will talk about Qatar Biobank, a journey to ISO biobanking and CAP accreditation. دكتورة إيمان الخياط سوري.
Good afternoon, everyone. Thank you for inviting us to this event. I would like to introduce myself. My name is Iman Al-Khayyat, is the lab manager in Qatar Biobank. Today, I will speak about journey to ISO Biobank and CAP accreditation. لا بس الشاشة من ظهره. لا Yeah, okay. I have no conflict of interest to disclose. In this presentation, we will introduce what our biobank, Qatar Biobank. We highlight our vision and mission. We introduce our study that included in a QBP and we also introduced the department included in the Qatar Biobank. Then I will speak about the certification and accreditation in the Qatar Biobank that we achieved, like ISO and CAB accreditation, and also the challenges that we facing when achieving the accreditation. Then I will conclude with a small comparison between the different accreditation. First, Qatar. Qatar is Peninsula Persian Gulf, population of 3 million, which over 300,000 of Qatari nationality. It is innovative, exciting, balancing between traditional root with modernity. What is Qatar? What is Qatar Biobank? Qatar Biobank is center of research for collection of sample and information on health and lifestyle from large number of members of population of Qatari and long resident. Qatar Biobank is located in the central of Doha, mainly in the medical city, and under Qatar Foundation, which is non-profit organization for education, science, and culture development. It is collaboration with Hamad Medical and the Ministry of Public Health. In Qatar Biobank, we have our vision and mission. We act as Qatar National Center for Samples and Data, and our aim to enable research toward new healthcare intervention and personalized healthcare for the benefits of people in Qatar and worldwide. Now I will speak about our study. We have multi-nested study in our QBB and other study also included. All of them have IRB approval by our scientific team. We have cohort study, Qatar birth cohort, COVID-19, and others like diabetes and stroke. For cohort study, our aim to collect sample and data from Qatari population and long-term residents. Our aim to reach it to the 60 participants. Now we have reached to more than 30,000 participants. In Qatar birth cohort, our aim to collect sample from mother during pregnancy and after delivery, child and father. Our aim to collect information about the impact of environmental exposure and genetic factors on health for children, on health and well-being of children and their parents. And finally, we have COVID-19, which was established through the pandemic. Our aim to collect the sample from infected patients and vaccination, and to help the researcher to find the treatment and prevention of SARS-CoV-2. What is unique in Qatar Biobank? Qatar Biobank is recruit the participant independently, healthy participant. We offer them a luxury experience, a full checkup with multiple tests and analysis of more than 70 biomarkers, and that's why we have multiple departments to cover the whole operation in the QBB. These departments are booking, clinical, laboratory, IT, medical office, and scientific research. And in any biobank, the quality is the main essential. In order to ensure that we're providing the service, sample, and data for our customer with highest quality, which is complying with international standards. In Qatar Biobank Laboratories, we are spending much time in developing and focusing on the quality of the processing of our sample. All of our samples are fully automated, and each and every sample goes through different quality steps before its storage. And in order to ensure that we are meeting the international standard and the quality requirement. As I mentioned in the previous slide, to ensure we are providing service, tests, samples, and data of highest quality, QBB achieved accreditation and certification, include 3 certification of ISO and 1 certification of College of CAP. The first certification, ISO for Quality Management System. The second, ISO for Information Security Management System. The third, ISO for Biotechnology and Biobanking. The fourth is College of American Pathologists, which is a CAP accreditation. Our journey was started since 2013. We obtained and achieved the Quality Management System and Information Security System for those certificates in 2014. And we are able to maintain and renew those certificates in 2017. In the 2020, we got our CAP accreditation in the clinical part of the lab. And in the 2022, we renewed our CAP accreditation, and we achieved also the ISO biobanking certificate. What is the quality management system? The quality management system is a set of a procedure and a process which aim to ensure that the quality of a procedure and service meets or exceeded the expectation of customer satisfaction. There are 7 standards under a quality management system: the leadership, customer focus, engagement of people, improvement, decision-making, and also decision-making and management improvement. What is the information security in the QBB? The information security in Qatar Biobank is a set of policy and procedure for managing the organization sensitivity data. The goal to minimize the risk and protect our data securely and confidentiality. There are 8 standards about information security, include scope, leadership, planning, support, operation, performance evaluation, and improvement, and organization context. For ISO Biobank, we include requirement designed to demonstrate the competency of biobank operation and ability to provide biological sample and data to our research and customers. What is the ISO standard overlapping? Between the 3 standards have much in common. When we achieved the ISO quality management system and information security management system was of a great help when we start work in ISO Biobank, as the 3 standards have much in common. Between the 3 standards, there is overlapping, like leadership and commitment, and management review, non-conformity and corrective action, documented information, internal audit, continuous improvement, and performance evaluation. This is the clear picture showing the different clauses that overlapping with each standard. And also there is unique standard to each, there is a unique clause to each standard. With all beginning said, we thought that when we achieve it, when preparing the ISO biobank would be easy because we already have the ISO certificate. But, and not this the case, there is some challenges that we are facing when preparing the ISO biobank. And I will discuss some of them in next slide. And I will discuss also, in addition to that, the overlapping clauses and unique clauses between the three standards. First, I will speak about the overlapping clauses. First, we have the overlapping area, example, the risk. The clause 6.1 in the quality management system, the action to address risk and opportunities. There are the same risk in the information security management, action also to address risk and opportunities, and also in the ISO biobanking, there is a clause 8.1.2, action to address risk and opportunities. What is also, there is another example, like the competency, it is overlapping between the three standards. What is the unique clause for ISO biobanking? We have one example of control of non-conformity output. In the quality management system and information security system, the clause non-conformity and corrective action, no risk assessment required. But in the ISO biobank, in the clause 7.11.2, the control of non-conformity output, the risk assessment required. The action was taken by biobank. We implement the risk assessment in our action request procedure. And also there is another unique clause like date and time format, which is not required and not required of standardization in both ISO quality management system and information security management system, but in the ISO biobank in the clause 7.2.1.1, the date and time documentation should be formatted according to the ISO 8601. What are the challenges we facing when we prepared the ISO biobank? The first challenges was with this clause 7.7 about the storage inventory validation. As there is no, the biobank should verify the biological material inventory. As there is no standardization or specification, as we have 3 different locations of storage, we storage our sample in automated -80 biostore. Also, we store the sample in other location in a cryopreservation in -196. Also, we store our sample in the normal upright freezer, the manual one. We take the action and we implement our plan. We decided the percentage we can retrieve it from different locations. We agreed to retrieve 0.01% of total samples stored in biobank. We check the condition of the aliquot. We check the location, if the incorrect side according to the software, and we check also the labeling. Another challenge that I believe is applicable for most of the biobank is the clause of the should be fit to the purpose. Method fit for their purpose. As the very clause 7.8.1.2. As the biobank is very complicated to identify the final use of our sample, and although we are commitment with the provide sample with highest quality, complying with international standards when applicable. However, we don't know the destination of your sample. It is challenges to ensure that your method or procedure is perfect and fit for the end purpose. And also, there is still some method lacking of standardization, which take us to the next slide. Last challenges that we face, I will discuss related to the clause biobank should provide evidence of equality that is comparable with other biobank. However, for some of a process, there is lack of standards or materials. In order to harmonize the different process of biobank to make it is comparable with other biobank. As there is no standards, no protocol, will be no standards for reference material. I am sure one of the aim standard is the overall of standardization of the process to meet the overall of equality in the biobank. For example, if any research from different parts of the world want the report based on our sample or data, Qatar Biobank take the action and implement the interlaboratory validation plan with governmental Hamad Medical Corporation for some sample. And also, we implement our quality report to provide it to our customer research about our samples. هو الكمبيوتر واتساب كمبيوتر لا هو علق slideshow. Okay. Okay. We complete now our presentation. As I mentioned in the previous, QBB has a 3 ISO certificate and CAP accreditation, which stands for College of American Pathologists. Now we are more focusing on the CAP accreditation that was given to the clinical part in the QBB laboratories to process the clinical sample on the Qatari ship, which is basically genotyping solution to screen the Qatari population for health and wellness status. What the challenges we facing in the CAP? The most challenges that we facing in the CAP about the safety requirement. For example, as per CAP, there should be a specific area for collecting the liquid waste. So we had to create one in our laboratories. And one of the requirements also was not to keep any boxes on the floor. It is not allowed. We should put it on the shelves. We created more shelves in the lab to keep it all the boxes and consumables, and that to avoid any deficiency in the inspection. And many other requirements. Now we will talk about the proficiency test, what we're facing in the CAP challenges. As we do unique tests and customize it by Thermo Fisher and our QBB and the QGB center, we have mentioned before as we need required developed test for customized and unique test. There is no proficiency testing material available in the general of the CAP. So we had to go with alternative performance testing and perform inter-laboratory also comparison with CAP accredited laboratory, like with Hamad, and we doing with other company in the USA, like Sampled Company, with their specific frequency and passing criteria. Here, the comparison between the CAP accreditation and ISO Biobank. The CAP accreditation is focused more on the clinical testing and to provide the best service in terms of a clinical test for patients. And it focuses on the clinical procedure itself and anything related. And it's different checklists to follow. Like we have general checklist, safety checklist, and molecular checklist because we do molecular tests, which I mentioned in the previous. It is microarray Q-chip test. On the other hand, the ISO Biobank focus on overall process in the biobank and workflow, including storage of sample, processing of sample, how to distribute the sample to the research, and with the highest quality, and the data for the research complying with international standard. The comparison will be more efficient between ISO Biobank and CAP Biobank, which is an accreditation that we are willing to go for a future in QBB. In the end, the biobank is a bridge to research and the precision medicine. It is great to have standards and accreditation as it is the first step to create harmonization between all biobanks around the world. Let me finish my presentation by acknowledgement. My thanks to my director, Dr. Nahla Afifi, our professor and director in the QBB, our team in the biobank. Without them, we could not achieve what we achieve it now. And thanks for everyone. And we all have different challenges. And I hope in my presentation, I highlighted some challenges, and we are facing that we are facing in the QBB, and it would be helpful for all. And thank you for everyone, and I hope to see everyone in Qatar soon, inshallah.
Thank you, Dr. Iman, for this comprehensive and excellent talk.
Thank you.
The floor is open for discussion now. Any questions for any speakers?
For what exactly? We have for ISO Biobank, as I mentioned, we have ISO QMS 9001.
Which accreditation body accredited for 2000? Your third party give you the accreditation. Have you a national accreditation body in Qatar, or you have from ILAC? The ILAC. Yeah. Okay. That's her question. From ILAC.
Okay. Yeah.
A2LA. Okay.
The ISO Biobank. Thank you.
So thank you to all the speakers for the very interesting presentation. I would have one question for Engineer Mahmoud regarding accreditation. You gave a very nice overview and comprehensive overview about what is exactly the accreditation. So we had the what, we had the how accreditation process is working, but I would like to ask a question about the who. So you mentioned about the beneficiaries of the accreditation, but what about the person that will assess all this process for obtaining the accreditation? Do you think that it could be a new kind of job for the biobankers who will assess this kind of skills, competencies to obtain the accreditation?
You mean the consulting, oh, you mean the assessor, or, yeah, the assessor, those are the impartial assessors from the accreditation body itself.
But are there biobankers?
Yes. The assessors, you know, this is normally the assessor in each field. They are selected based on their competence in the specific field. So they are selected. Each accreditation body has access to the assessors' committees and decision making before they start the scheme. So this is an important issue for the accreditation body to have. In Egypt here, we already have one workshop and training to assessors, and yes, they start for access to those qualified assessors to make the assessment on the biobanks.
Any other question? كان نفسنا ما اعرفش دكتوره مريان كان في النيوز ايه لسه موجوده ولا لا for discounting for the Egyptian for this system $240 much. Okay, thank you, and now for closing for this session, and see you in the next one after break. Thank you.